Hello viewers, welcome to MST online class. I am MST Kumagbe. You can subscribe to my YouTube channel MST online class, follow me on TikTok MST online class, and of course on Facebook MST online class and MST Kumagbe. Today's video we're learning chemistry and the topic of our discussion is electrolysis. At the end of this video, I expect the student should be able to define electrolysis, explain the meaning of electrolyte, electrode, anode, cathode, and of course they should be able to state Faraday's first law of electrolysis. Now, by way of introduction, electrolysis can be defined as the chemical decomposition of a compound that is brought about by the passage of electric current through the solution of the solution with the molten compound. Now, we have some terms that we need to know. This is just an introductory video on this topic, and we have some key terms that we're going to be using subsequently. Now, first is electrolyte. What is an electrolyte? An electrolyte is a compound that conducts electricity. An electrolyte is a compound that conducts electricity. Examples, we have sodium chloride, we have potassium hydroxide, and of course the likes. While non-electrolytes do not conduct electricity. Non-electrolytes do not conduct electricity. Now, of course, the second term, we're going to learn the meaning. Its meaning is electrode. An electrode is like a plate or wire through which electric current enters or leaves the electrolytes. This is like a plate or a wire through which electric current enters or leaves the electrolytes. Of course, we have anode. Anode is a positive electrode. Anode is a positive electrode. Of course, we have cathode, which is a negative electrode. And I'm going to use this figure. This is a simple electrolytic cell. I'm going to use this figure to explain the meaning of the terms. Now, this is a positive electrode. This is an electrode. This is a positive electrode. This is a negative electrode. And by our definition, I say that an anode is a positive electrode. So this is a positive electrode. So we can say that this is an anode. This is an anode. This is a cathode, which is a negative electrode. So both anode and cathode are electrode. Both anode and cathode are electrode. Because they are like channels through which the electric current will enter the electrolyte. Now, what you are seeing here is an electrolyte, a solution of an electrolyte. So this is an electrolyte. And these are free moving ions, both positive and negative ions, moving freely in solution. So this is an electrolyte. So this is a simple electrolytic cell, and then this is the direction of electron flow. This is the direction of electron flow. This is the direction of electron flow. So that is it about that. So I've used this figure to explain the meaning of electrolytes. Is electrode, anode, and cathode. Now the next thing we're going to learn, due to brevity of time, I'm going to be very fast. The next thing I'm going to learn is Faraday's first law of electrolysis. Faraday's first law of electrolysis. Now we want to study Faraday's first law of electrolysis. Now, the quantitative relationship between the amount of electrolysis and the quantity of electricity was investigated in 1822 by a scientist called Michael Faraday, and then he brought about two laws of electrolysis. Of course, the first law of electrolysis and the second law of electrolysis, which we're going to learn in our subsequent videos. Now, for this video, we're going to learn Faraday's first law of electrolysis, and the law states that the mass m of an element or a substance deposited at the electrode during electrolysis is directly proportional to the quantity of electricity passing through the electrolytes. Now let's see the mathematical statement of that law. Now the law states that the mass m, if you denote the mass by m, the mass m of an element or substance deposited at the electrode during electrolysis is directly proportional to the quantity of electricity passing through the electrolyte. So if you denote if you denote mass by m, and of course quantity of electricity by q, then the law states that m is directly proportional to q. M is directly proportional to q, where m is the mass and q is the quantity of electricity. Now if we introduce an equality sign, then we have m being equal to zq. Let's call it equation 1. Let's call this equation 1. We have m being equal to zq, where n is still the mass, z is the constant, and of course q is the quantity of electricity. I want to know what z is subsequently. Now recall that q, that is quantity of electricity, is equal to current in ampere times time in seconds. That is, q is equal to current times time, and of course current is measured in ampere and time is measured in seconds. So the q is equal to current I times time t, so q is equal to it. So this our equation 1 will change to changes to m is equal to zit. Let's call it equation 2, where m is still the mass in gram, z is our constant, I is current in ampere, and t is time in seconds. Now I'm trying to define z now. We're going to know z now. I'm trying to define z. Now if I is 1 ampere, that is, if the current is 1 ampere and time is 1 second, then m will be equal to z, because 1 times 1, if current is 1 ampere and time is 1 second, that is 1 times 1 is still 1, times z is still z, so m will be equal to z. So m is equal to z if I, that is current in ampere, is equal to 1 ampere and t is equal to 1 second. M is equal to z. What then is z? Z can be defined as the mass deposited when a current of 1 ampere passes through an electrolyte for 1 second. It is a mass deposited or discharged when a current of 1 ampere passes through an electrolyte for 1 second, and it is referred to as electrochemical equivalent. It is referred to as electrochemical equivalent, and of course it is a constant. It is a constant. So that is it uh, about electrolysis. Now in our subsequent videos we're going to learn Faraday's first law of Faraday's second law of electrolysis. Of course we're going to step into calculation, and of course more calculations. So if you're interested in this video, don't forget to like and share. Also subscribe to my YouTube channel MST Online Class. Follow me on TikTok MST Online Class, and of course on Facebook MST Online Class and MST Kumagbe. Thank you so much for watching, and God bless you. See you in the next video.